Hello, my name is Benedikt Spielmann. I'm product manager at GF Piping Systems. And in this video series, I will give some insights into the topic of digital field connectivity for process automation plants. This comprises both theoretical insights, but also hands-on experience how to set up such digital connected networks. For today, we focus on the theoretical introduction to digital field connectivity. And I will start this with the question, why do we need it? Why do we talk about this topic of connectivity? For this, we can see here a typical P&ID, which is the starting point of the planning phase of a process plant. By taking a closer look, we can spot several process automation field devices, like sensors, but also actuated valves. In a traditional way, those field devices are connected to a PLC, which is installed in a cabinet. And at this PLC, several input-output cards are connected. And as you can see in this visualization here, we need this point-to-point connection, which means one cable from each and single device back to the cabinet to those I/O cards. Doesn't look so complex in this very small plant, but if you scale it up to bigger plants with 100 or even more devices, you can imagine the increasing effort for the initial cabling. Also, by taking a look to a cabinet, we can see it needs quite a lot of space because we need many input-output cards. In this example, it's well structured. Every cable is marked with the name of the device. But in reality, you can also observe such examples. And then it's really a nightmare for doing some troubleshooting of the network. So what are the pain points with analog networks like 4 to 20 milliamp? First of all, we have those input-output cards. Those cards become more and more expensive nowadays. In addition, depending on the size of the plant, it needs quite a lot of cabinet space, which is a big pain point for very compact process plants, like containerized solutions for water treatment, for example. I was already talking about the cable effort, which is actually the biggest pain point for our customers in the initial setup of the process plant. And besides of all those hardware-driven and physical issues, we have also the lack of additional device data. Our devices, they produce a lot of valuable data, but with 4 to 20 milliamp technology, this data is locked in the device. So how to improve the situation? For this, let's take a look to the classical automation pyramid, how it looks in the process plants. Here on this level, we have the control level with the PLC. And then on the upper levels, we have SCADA systems, MES systems, ERP systems, and so on. And for the connection of those levels, we are already using Ethernet technology. This is state of the art for many decades already. However, for the connection of the control level and the field level with the actuated valves and sensors, we are still using other technologies, predominantly 4 to 20 milliamp. Sometimes we can also observe field bus installations like Profibus or Modbus RTU. The goal is to bring Ethernet technology down to the field level. By this, we can achieve a seamless data access across all the different levels of the automation pyramid. Industrial Ethernet, it's a well-established technology already in the factory automation, and it comes more and more also to the process automation world, so to water treatment plants, for example. We can see here over the timeline that industrial Ethernet, which is marked in the green bar here, gains more and more market share already. Field bus installations, which are marked in red here in this example, the market share of those technologies decreases. And also the total share of field devices equipped with 4 to 20 milliamp in the installed base, it decreases already. And the prediction is industrial Ethernet-equipped devices will gain much more market relevance in the upcoming 10 to 20 years. When we talk about Ethernet in the world of industrial environments, there are 3 most important industrial Ethernet protocols. We will take a look to those protocols in the later episodes of this video series, but just that you have heard about it. Profinet, mostly associated with Siemens environments, Ethernet IP, associated with Allen Bradley or Schneider PLCs, and Modbus TCP. Those are the most important protocols in terms of industrial Ethernet. We, as GF Piping Systems, we have started this journey to equip our field devices with those technologies. Here you can see our portfolio, here also in live. So on the actuation side of our portfolio, you can already order electric actuators with Profinet, Ethernet IP or Modbus TCP. You can mount those electric actuators on any kind of valves, butterfly valves, ball valves and so on. But also on the pneumatic side, we have an industrial Ethernet solution. So pneumatic actuators for rotary, but also for stroke valves. You can additionally mount a positioner on top, which is equipped with industrial Ethernet, and by this you can achieve all the advantages that comes with those technologies. How does such an Ethernet-equipped network topology look like, and what are the differences compared to an analog world? Again, we have here a PNID of a process plant. In this example, we have several actuated valves in the process plant. Of course, it's still needed to have any kind of control system, so a PLC. But here we can see the first difference compared to analog worlds. We don't need any I/O cards because it's possible to go out directly from the cabinet, from the PLC, with one single cable down to the field level. And there we have the complete flexibility how to connect all those devices with each other. As you can see it here, in this example, we have a so-called line topology where we connect one device directly with the other. But it's also possible to set up such a star topology where we go from an Ethernet switch to the different segments of an Ethernet of the process plant. It's even possible with Profinet and Ethernet IP to close this ring, which has many advantages in terms of high availability of a process plant. In case of a cable break somewhere here in the line, it doesn't matter because the communication just goes the other way around. Let's take a look to the data side. Of course, the basic functionality of the actuated valves is still maintained, which means it's possible to steer open or close the valve. In addition, there is so much additional data available, like the motor current, the device temperature, and also a lot of diagnostic events. So the device monitors the health status of itself and can give the detailed diagnostic event to any kind of customer system, which brings a lot of increase in efficiency on the customer side because there's no need to go locally to the device to check the root cause of the error. In addition, with industrial Ethernet, we are using the functionality of providing an embedded web server. It's embedded in the device, and it can be accessed from anywhere in the network. And in this web server, you will have a lot of additional features which can increase your efficiency in daily operations. Again, everything around additional values, additional diagnostic insights, but also very nice features like teaching the end positions of the valve, for example. And in addition, in terms of cybersecurity, this embedded web server, it's also certified according to the global cybersecurity standard, which is specified in an IEC standard. So to summarize the advantages of industrial Ethernet in the field level, you don't need any I/O cards to connect the field devices, which means your cabinets become smaller. You can significantly decrease the cable effort in the initial plant setup, which makes it also very easy in terms of troubleshooting the network. And in terms of Industry 4.0 or the industrial Internet of Things, you can access any kind of device data, which provides you additional possibilities in terms of predictive maintenance or optimizing maintenance personnel. That's for the introduction today into digital field connectivity. Stay tuned for the following episodes where we will go into more detail, also including hands-on experience, and we will take a closer look to the devices itself, how it works with the GF Piping Systems portfolio. Thank you.